Example 6.5, the ballistic pendulum. This is a device you can use to measure the speed of projectiles, like bullets. The way it works is you shoot a bullet at a block of material that's hanging with a string or rope or something. That bullet gets embedded into that block in a perfectly inelastic collision. And then those two objects move together. They acquire some speed right after that collision. That's the speed given by our perfectly inelastic collision formula. And this moves up, swings up to some final height, at which point gravity has slowed it down. So there's our final height. By measuring the final height, you can then infer what the initial speed of the bullet was, as long as you know the masses of the bullet and the block. So let's do that. We have a 5-gram bullet, a 1 kilogram block. We perform this experiment. We measure that the block rises 5 centimeters. So the first step is to figure out what that speed was immediately after the collision, what this kind of speed was. We can do that with conservation of energy. So right after this collision occurs, the block with the bullet embedded starts moving and swings up to some height, and energy is conserved during that portion of the motion. There's no collisions happening, there's no heat or sound being generated. It's fine to use conservation of energy for that part of the motion. So let's do that. I should have written M1 plus M2. There. Here's our initial potential energy, gravitational potential energy of the block with the bullet embedded. There's the initial kinetic energy. This is our unknown that we'll solve for. And that equals final potential plus final kinetic. Now in this final state, there's no kinetic energy. It's come to a stop. And we might as well say that y initial is 0. We might as well measure height relative to the bottom position of that block. So we can cross that out. And now we have some algebra. We'll cross out these masses. They divide from both sides, and we find that the speed right after the collision is 2g times y final. Y final is just that height h, square root. And when you plug in that value of h, you get 0.990 meters per second. Okay, so we have the value for the left-hand side of this equation. And now in part B, we want to figure out what V1 was after all. So I'll just back up and go to this previous line of the equation, because that'll be more useful for us to solve things. M1 V1 initial plus M2 V2 initial equals M1 plus M2 V, I guess we're calling it V system. M2 started out stationary, so we can cross that term out. And we now have this result that V1 initial is V system times m1 plus m2 divided by m1. I just divided both sides of the equation by m1. And plugging the numbers, we find that that bullet was traveling at 199 meters per second. That's the ballistic pendulum.